Objective: to calculate the number of atoms in a unit cell. We know that every crystal lattice is made of infinite number of unit cells, and every lattice site is occupied by a constituent particle that could be an atom, an ion, or a molecule. Now let's find out what fraction of each particle belongs to a particular unit cell of a crystal lattice. Let us consider three types of cubic unit cells, and for ease of understanding, let's assume the constituent particles to be atoms. To begin with, we will consider a simple or primitive cubic lattice. A simple cubic lattice has 8 atoms, one at each of its 8 corners. Please note that the distances between the atoms are greatly exaggerated. In the real scenario, the atoms are packed together much more closely. The space-filling model that you see shows the atoms touching each other along the edges of the cell. We can generate a unit cell of a simple cubic lattice by considering a portion of atoms within the cell boundary. We can clearly see that each atom contributes 1/8 of its original volume to each unit cell. So, as there are 8 atoms at the 8 corners, the number of atoms in each unit cell is equal to 8 corner atoms multiplied by 1/8 of an atom per unit cell, which is equal to 1. Therefore, the total number of atoms in a simple or primitive unit cell is 1. In a body-centered unit cell, there are 8 corner atoms, and there is 1 extra atom at the body center. As a result, the atoms at the corners, as shown in the space-filling model, no longer touch along the edges of the cell. As you can see, each of the 8 atoms at the corners of the unit cell of a body-centered cubic cell contributes 1/8 of the actual volume. And one of the atoms lies completely within the cell. Therefore, the number of atoms at the corners per unit cell is equal to 8 corner atoms into 1/8 of an atom per unit cell, which is equal to 1. In addition, there is 1 atom at the center of the cube. So the total number of atoms in a body-centered cubic unit cell is 2. Now, let's look at a face-centered cubic lattice. Here, there are 8 atoms at each corner. Other than the 8 corner atoms, there are 6 more atoms at the 6 faces of the cubical cell. The atoms touch along the diagonals, and each one of them touches the 4 atoms at the corners. Observe the unit cell of a face-centered cubic cell closely. Clearly, each of the atoms at the corners contribute 1/8 of their original volume. Furthermore, each of the 6 atoms at the 6 faces contribute half of their original volume. The number of atoms at the corners per unit cell is equal to 8 corner atoms multiplied by 1 by 8 of an atom per unit cell, which is equal to 1. The number of atoms present at the faces per unit cell is equal to 6 atoms at the faces multiplied by half an atom per unit cell, which is equal to 3. So the total number of atoms per face-centered cubic unit cell is 4. Let's summarize. The total number of atoms in a simple or primitive unit cell is 1. The total number of atoms in a body-centered cubic unit cell is 2. The total number of atoms per face-centered cubic unit cell is 4.